Hi, ladies and gentlemen. Here we are again for another edition of the Cameroon Town Hall for Healthcare Professionals. This is your platform where we bring together healthcare professionals from Cameroon who are spread across the globe every fortnight for us to have a conversation on important health issues affecting us and how we can contribute to upgrade the health system in Cameroon. We've had more than 30 editions so far, and we continue to have these regular meetings every 2 weeks and on Saturday, and it's always at 6 p.m. Cameroon time and 1 p.m. Eastern time. So we are really glad to have you once again here. Thank you for joining in for those who are already tuning in, and we also hope that we are going to be on for another 2 hours, 30 minutes of a very important and interesting conversation. Today, I will be moderating with Christelle, and one of our moderators is going to be the presenter. And so, of course, he's going to relinquish his moderation role. And unfortunately, we might not be having Alison today because of other commitments. And also, I'll be checking to see if Louisa Viban will join us. Christelle, welcome. Christelle, it's like you're mute. I can't hear your volume, or maybe it's on my end.
C'est bon maintenant?
Yes.
Ouais. Merci Elvis, bienvenue à chacun et à chacune à cette nouvelle édition de Cameroon Town Hall pour laquelle nous allons discuter aujourd'hui avec le soutien du Dr Kenji, les variants, notamment le variant Delta. Merci encore et nous sommes ravis de vous avoir.
Thank you very much, Christelle. And as you rightly said, this week we shall be talking about how dangerous is the Delta variant of COVID-19 virus. So we are going to have our own regular voices in the house, Dr. Kenji Mfuobadia, who is head of one of the biggest virology lab in California in Stanford University. He is a trusted authority in this domain, and he is going to be handling it with Dr. Brian Tegomo, who also works with CDC and has a lot of insight on how to trace the different mutations of this virus. And he'll be actually giving us some insights on the Delta variant and how the mapping across the globe is concerned. And so last week, I would want to remind us that we had a conversation on cardiovascular surgery in sub-Saharan Africa, how sustainable it is. And we had a very, very interesting conversation from our own brother in Germany. So this time around, we shall be having our own Kenji. Welcome back from a long trip. I know you went out of the United States somewhere around the globe, and welcome back. I don't want to disclose where you were, so welcome.
Thank you so much. I was somewhere minding gold.
Thank you very much. And of course, we always have the pleasure to thank our own chairperson, Dr. Muno Kenneth, who works a lot to put together this town hall, the topics, the experts. We always do a lot of work at the backstage. I want to thank you for your continuous commitment and leadership. And once again, you're welcome to this edition, Dr. Ken.
Thank you, Elvis. Thank you very much.
Good. And of course, are we going to have updates today, or we will just be talking the variant? What do you think?
I think we should go straight to the variants. It's very important. I think it's what is making the news, and that is what is the update. So I would leave the experts to talk about it. And it looks like Brian will not be able to join us today due to some unforeseen circumstances. And Dr. Kenji is going to cover this discussion, I think so.
That's interesting. And Kenji is the man of the topic. So that is going to be an easy ride for him. So Ken, before I hand over to you, just permit me say something about the COVID-19 and vaccination, because we've had this question several times from people. Why is it that I get the vaccine and I still get the virus? And also, of what use was it for me to get the vaccine if I will still be exposed to the virus and all that? So I thought that we could just get this across, maybe so we could brighten our understanding on the importance of vaccine at personal level and at population level. So while the reduction in risk of a disease is arguably the most relevant vaccine effect to the individual participant, understanding the population effect of a vaccine requires considering other effects of the vaccine. So the most fundamental effect of a vaccine is to reduce acquisition of infection, and sometimes referred to as vaccine efficacy against susceptibility. But a vaccine that reduces acquisition of infection will provide benefit to the individual, that is the direct benefit, as well as benefit to the population by reducing the number of infected and therefore potentially infectious individuals who may expose and infect unvaccinated individuals in the population. That is now what we call the indirect effects of a vaccine. And so in addition, an additional potential indirect effect of a vaccine is its effect on reducing secondary transmission of the infection. A vaccine might reduce transmission through reducing the magnitude or duration of the viral shedding by reducing symptoms associated with transmission, such as coughing, because when you cough, of course, transmission is more, is increased. So by reducing symptoms like coughing or by selectively blocking infection with less transmissible viral strains. So evaluating the effect of a COVID-19 vaccine on transmissibility is critical because a vaccine with high efficacy, and I repeat, listen to this please, a vaccine with high efficacy against COVID-19 disease, but with low efficacy against SARS-CoV-2 infection would necessarily yield a net increase in the number of asymptomatic infections. And if this happens, if individuals who become asymptomatically infected despite having received the vaccine are still infectious, and given that the asymptomatic individuals are less likely to be diagnosed and self-isolate, in this case, they'll spread it more. Such a vaccine will prolong the pandemic, despite the fact that it has a very good effect at individual level for preventing people from getting the serious disease if they get infected. So the most effective way of a vaccine to prevent onward transmission of infection is to prevent acquisition of infection. And so when we're talking about the variants now, we should have in the back of our mind that the initial objective when COVID-19 started for looking for a vaccine was to prevent severe disease and prevent people from getting into ICU, getting into ventilation and dying. But once that has been achieved by 94% averagely for most of the vaccine we have, the next question was about preventing transmissibility. And that is where we are. Kenji, that's where I hand over to you. How then can we talk about the Delta variant while dealing with issues of transmission and issues of vaccine? Over to you. You are the man of the topic.
Thank you so much, Elvis. Let me share my screen right here. Let me see. Elvis, are you sharing your screen?
I stopped sharing my screen already. I'm sure you're the host to it.
I think, let me see.
Yeah, we can see your screen.
Okay. All right, that's good. Let me just put this on. Is it okay now?
Yes.
All right. Thank you so much. Thanks, everyone. Thanks, Elvis, for the wonderful introduction. I was to do this talk with Brian. Unfortunately, he has an emergency. He was to take the first part of the discussion, but I'll just do my best to, just put everything into context as we move on. So I thought we'll just start a little bit with some basic virology, just to give us some context, on what we'll be talking of today regarding the variants and all the like. I know this probably so basic for most of you, but the first question I want us to look at is, how do viruses cause infection? And one way I want us to look at it is, just take, for example, you come back from work after a very hectic day, then you mistakenly take your car keys and you try to open the door of your house with, most likely it's not going to open because that's not the key that's specific to that particular door. Or maybe you take the keys of your door and you try to open your car with, it's not going to go. So viruses must bind to a specific receptor that is found on the cell. If you look at the cartoon to my left, you can see this is the SARS-CoV-2. You see it has these projections over it that has to bind to a specific receptor on a cell. So if a cell is lacking that receptor, the virus is not going to go in. We've learned this from HIV, with people that have certain mutations or that lack certain receptors that the virus cannot get into the cell. So this binding must take place for the virus to get into the cell. So the fact that you have a virus in you, it doesn't necessarily mean that it's going to get into the cell and replicate in you. So you need to have that specific receptor recognition. So the receptor recognition actually defines the host range of the virus. as I said previously, if the host doesn't have that specific receptor for the virus to bind with, it's not going to infect that host. So we've learned over the years, that most of these infectious agents spill over from animal population. I mean, we've come to the understanding that even Ebola is circulating in bats, and we had that spill over from bats to humans. We've also learned from influenza viruses, from alpha viruses, including chikungunya, flaviviruses, including dengue, where there is that zoonotic, no arm of it, where the viruses were circulating in the animal population. Then after some time, the virus continue, as a virus replicates, there's that probability of mutation, especially RNA viruses. Just to put it a little bit into context, if you look at this cartoon right down here, this is bat coronavirus, right? So this is the coronavirus that was circulating in bats. Over time, the virus mutated in such a way that it is now able to infect humans, meaning that in its native form, it will not really infect humans because humans don't have those receptors that are specific, to the spike proteins of the bat species of it. So it's as a result of mutations that you now have all these changes that, you begin to have this spillover from the animal population into humans. Now we have a better understanding on how viruses cause an infection. Now, just say you are infected with a virus, how does your body respond to it? The reason I'm bringing this in is for us to understand, vaccines later on when we're talking about it. So just say this is the COVID, the SARS-CoV-2. You see these red projections on it, which is the spike protein. So one thing your body can do is to produce antibodies that's going to bind to the spike proteins and neutralize it. And that's what the vaccines do. And as you can see, I still put my lock and key down here. This interaction is very, very specific. So you have specific antibodies that bind to the spike proteins and neutralize it. Now, your body can also do something else, right? This is where the cellular arm of the immune system sets in, where instead of saying, hey, I don't really have time, to producing all these antibodies and all the like, I just want to destroy you. So it can now bring in what we call, killer T cells, and just destroy, the cell that has been infected with the virus. So you have, the humoral part of the immune system and the cellular part of the immune system that work together to be able to respond to a viral infection. Now let's move further to the core of the presentation for today. Sorry, I want to move this down a little bit. Okay. So viruses constantly change, as I said, through mutations, and over time you have new variants that are expected to occur. So the more the virus circulates, the greater the chance that new mutations are going to develop. So that's why, they always say health immunity and, get vaccinated, because once we get vaccinated, we can try to block transmission, because as long as the virus is transmitted, all what viruses want to do is to mutate. And once they mutate, you have new variants that are going to develop. I just show you an example here in this cartoon where you see just 1 point mutation, right, between the S1 and the S2 subunit of the virus, just brings in an entirely new variant. And this new variant can confer to it certain characteristics. That is why, you look at now, we have different variants of COVID-19. You now have the alpha, you have the beta, you have the gamma, you also have the delta. As you can see, they have different mutations at the level of the spike protein. Alpha has certain mutations, beta has certain mutations. There are some that are common to each. So depending on the type of mutation, it can confer certain characteristics to that particular virus. So that is why, what are some of those things, or why are we concerned, about these variants? Why don't we just stay quiet? Some of these mutations can give it the ability to spread more quickly in people. That's one of the things that we are worried about. And some of these mutations can lead to a decreased susceptibility to therapeutic agents, especially monoclonal antibodies. And some of these mutations can change the phenotype in such a way that the virus can cause, more severe disease and is able to evade specific diagnostic tests. For example, if the mutation occurs at a region where the primer is supposed to bind, that diagnostic test may kind of lack sensitivity. And most importantly, too, ability to evade natural vaccine-induced immunity. So these are some of the reasons why, we are concerned about variants popping up. So we are going to look at all these various things with respect to some of the variants that have been circulating, and now we'll just narrow it down mostly and focus on the Delta variant. So one of the first things, because the topic today is how dangerous, is the Delta variant. One of the things we've started to appreciate is that the Delta variant is more contagious. I mean, we've had publications, and I've done all the estimates regarding the R naught of the Delta variant as compared to other variants that are circulating. And, we are beginning to come to the conclusion that the Delta variant is 40 to 60% more transmissible as compared to the Alpha variant. Before the Delta variant, what was circulating was the Alpha variant. So the Alpha variant took over, the world. Now Delta has taken over, and now you begin to understand why. It is 40 to 60% more transmissible. But most importantly, I think this is one of the things that, kind of surprise us. As you know, with COVID, things change every day. If you look to my right, this is a publication that was released. Now you have the CT value, and you have the ORF gene that was identified. Now, there's an inverse relationship between the CT value and the viral load, meaning that if the CT value is high, it means the viral load is low. And if the CT value is low, it means the viral load is high. So in this study, they compared the viral load in people that were infected with the original SARS-CoV strain, and now in people that carry the Delta variant. Now, as you can see, the Delta variant in pink, it has a very low CT value, meaning that those that are infected with the Delta variant carry a lot more viruses as compared to those that were infected with the original SARS-CoV-2. And they have estimated from this study that viral load is about 1,000 times higher in people infected with the Delta variant as compared to other variants. Now, why is this of importance? Now, the fact that you carry a virus doesn't necessarily mean that you are able to transmit it. Now, the viral load really comes into place. The higher the viral load, the higher the chance that you are able to transmit that virus to another person. So that's why we always say, because you are infected, it doesn't mean that you are infectious, right? So being infected doesn't mean you are able to infect another person. So one of those criteria is the viral load. It's the same too, for HIV. You have people that have viremia that you cannot even detect with the current diagnostic tools that we have. So the probability of that person spreading HIV to another person is lower as compared to somebody with a higher viral load. And this is another study. If you look at to the bottom right. So what this study did was that if you are infected with COVID, they try to do contact tracing. So they now take your contacts and they try to observe them for a certain number of days to see if they are going to test positive for COVID. And what they did was that they were able to see that those, that had the Delta variant, the proportion of people that were testing positive after 2 days, 4 days, 5 days, meaning early on during the pandemic, was higher for those that had the Delta variant as compared to those that had the original SARS-CoV-2 infection. So this is, if you take all this together, it means that the Delta variant is more infectious, especially during the early stage of the infection. So you have high viral load, and you have a lot of people testing positive earlier after being exposed to somebody that was infected. Now, one of those things that we can start asking ourselves is, why is the Delta variant more transmissible, right? We've already given some reasons there in terms of the viral load and all the like. One of the things is to look at the mutations that occur at the level of the spike protein. As I said, the spike protein, that is what the virus uses to bind onto receptors that are found on the human cell. So there are several mutations that have occurred on the spike proteins, and I've underlined some of them here. All these mutations are very important. So most of these mutations, affect the immune response that's directed towards the antigenic region of the receptor binding protein. So if it affects the immune response, it means that it can probably make the antibodies that that your body have produced no longer able to neutralize the virus, or a drop in neutralization. Now, just to put it a little bit into context regarding one of these mutations, As I said earlier, if you look at the spike protein, it has to bind onto a receptor. But then the spike protein is not just, as simple as it looks. It actually has two subunits. You have the S1 and the S2. Now, the S1 subunit has to be separated from the S2 subunit. So a cleavage needs to occur between the S1 and the S2 subunit for that binding to take place and for fusion to take place. Now, the more accurate and faster this cleavage occurs, the faster the cell is infected with this virus. And if you have more of the viruses that are undergoing this cleavage, it means more cells will be infected. So what has happened is that there is a mutation in the Delta variant, and that mutation is referred to as the P681R. As a result of that mutation, what has happened is that this region becomes less acidic and making it now for the enzyme to recognize it and cut it effectively. So because of that effective cleavage, this now leads to increase in replication, higher viral load, and now increase in transmission. Now, this phenomenon is what is referred to as priming. So if you have more of the viruses that are primed, it means more cells are going to be infected, or the likelihood that's going to infect the cell is high. Now, if you compare the Delta variant with the original SARS-CoV-2, 70% of the Delta variants are being primed as compared to just 10% of the original SARS-CoV-2. So that tells you a lot, on how infectious this virus is, just because of a point mutation. So that's why, as we said, as they continue to replicate, you're going to have these mutations that are going to occur. And we really don't know, which mutation is going to pop up tomorrow. So that's why one of the best things, we can do is to encourage people to get vaccinated so we can stop the chain of transmission. Now, I'd like us to go, a little bit looking at SARS-CoV-2 variants and disease severity. Not much has been done regarding the Delta variant and disease severity, but some publications are beginning to pop up. And this is one of them, where they look at the percentage of people that had Delta variant that were hospitalized as compared to those that had other variants of concern that were not Delta, and those that did not have any variant of concern. So if you look at hospitalization, those that did not have any variant of concern, meaning that they probably just had the original strain of the COVID virus, 4.4% of them were hospitalized. And you can see, as compared to the Delta variant, 5.8% of those that had the Delta variant were hospitalized. Now, admitted to the ICU, now you're already talking about severe disease and all the like. If you look at those that were infected with where variants of concern were not detected in them, 0.8% of them were in the ICU, as compared to 1.5% of those that had the Delta variant. And of course, death, right? This is the hallmark, right? The most important thing is for people not to die. If you're infected, you have severe disease, we really don't want people to die. But if you look at, for those that variants of concern were not detected, 0.9% of them died, as compared to those that had Delta variant, 0.7% of them died. So these are the other, variants of concern that carry the N501Y mutations. I haven't spoken much about them. I just wanted to put this just so that we can compare the Delta variant with the original SARS-CoV-2 variant. Then they now went further to do, further analysis, looking at the odds ratio and all the like, where, now they are comparing hospitalization, ICU admission, and death in those that, probably had Delta variant, and in those that had, other variants that were not Delta. As you can see, compared to non-variant of concern SARS-CoV-2 strains, they adjusted elevated risks associated with the other variants that were not Delta. So it was 52% for hospitalization, and 89% for ICU admission, and 5% of death. But then if you look at Delta variant, it really went high. That was 108% for hospitalization. And if you look at ICU admission, it went up to 234%. And if you look at the rates of dying, was 132%. So I think this is one of the studies that have really tried to look at disease severity. You know, as I said, it is just one study, and it also has its own limitations too. As you can see, in terms of Delta variants, they were looking at probable Delta variants. So it's not as if they were very sure. There could still be some misclassification in terms of the Delta variant, but at least it is giving us a story. It is telling us something, that the Delta variant seems to be causing more severe disease as compared to the Alpha variant that was previously circulating. Because if you look at the table to my right, if you look at the odds ratio, where you are comparing Delta variant and the Alpha variant for hospitalization, it was 1.4, ICU admission was 1.8, and death it was 1.5, just telling us that the Delta variant is probably causing more severe disease as compared to the other variants that were circulating. Now let's drive a little bit now towards vaccines. You know, looking at the effectiveness of the COVID-19 vaccines against the SARS-CoV-2 variants. Now, what they did in this study is that they collected blood samples from people that took the Pfizer vaccine and people that took the AstraZeneca vaccine, because it's good to compare, you know, an mRNA vaccine and also a vector-based vaccine. So I think it was a cool study design that they did. So they took their blood sample, you know, got their serum, because that's where the antibody is present. And they now looked at the ability of these serum samples to neutralize the original COVID virus and also the Delta variant. So what they did is this an experiment that, you know, we usually do in the lab. Not to bore you much about the experiment, but what they were seeing is that if you look at the original COVID virus as compared to the Delta variant, you see this sharp drop in neutralization potential. As I told you previously, when you're infected with a virus, one of the things that your body does is to produce these antibodies, and what the antibodies will do is to neutralize that virus. So they realized that, you know, there was a 2.7% drop in the ability of those serum samples to neutralize the Delta variant as compared to the original SARS-CoV variant. But then, you know, when they went now, you know, using serum samples from people that received the AstraZeneca vaccine, they also realized that there was this 2.6% drop in terms of its ability to neutralize the virus. So all this taken together, you know, shows us that, you know, the vaccine and convalescent sera shows reduced neutralization of the Delta variant. Now, if you look at the other figures, D and all the like, now they compared not only the original SARS-CoV variant with respect to Delta, they also had the other variants as well. And you can also see, especially it was pronounced with the B1351, which was first identified in South Africa, where there was this huge drop in neutralization potential up to 7.5%, 7.5 times drop in neutralization potential. But then, you know, as we always say, this is just one arm of the immune system. So the fact that you have a drop in the ability to neutralize the virus doesn't really mean that the vaccines are not effective, because you also have the cellular arm of the immune system that also has a role to play in this. So this is still, you know, another study that kind of looks at the neutralization potential. Of course, you know, I like it when they have the mRNA vaccine and the adenovirus vector vaccine. It's the same story, you know, just to reiterate what I said. They saw this drop, you know, in terms of the ability, you know, of the serum or of the serum samples to neutralize the Delta variant as compared to the original SARS-CoV variant. Now, this is now real world data, because all what I've been saying regarding neutralization and all the like, those are all laboratory experiments. And as I said, that's just one arm of the immune system. So now this is the efficacy itself of the COVID-19 vaccine against the Delta variant. And this is a good publication that was submitted to the New England Journal of Medicine. Now, I would like us to separate it into two. Now, vaccine efficacy after the second dose. That's where I want us to start. So what they did in this study is that, so you have the mRNA vaccine and you also have the adenovirus-based vaccine. So in terms of its efficacy, after 2 doses of the vaccine against the Alpha variant, it was 93%. as compared to the Delta variant, which was 88%. So what we are seeing is that there is a drop in terms of efficacy, but this drop is not really pronounced, right? There is some drop, but at least it's still efficacious, having something that is 88%. But then when you go to, the adenovirus-based vector vaccine, if you look at the alpha as compared to the delta, there's also this drop. And this is something that we already saw from the clinical trial data, right? In terms of efficacy, seeing that the mRNA vaccines showed showed a higher efficacy as compared to the vector-based vaccines. But then they also looked at efficacy if you took just one dose, right? So if you took just one dose, you see that the efficacy really drops, right? If you look at the alpha variant, it was just like 30% as compared to the delta, which was like 48%. So it was a huge drop if you take just one dose of any of the vaccines. So this is a cumulative data where they took all the study participants that had both the mRNA vaccine and the adenovirus-based vaccine. And if you took both doses, I mean, the first and the second, if you look at the efficacy of the vaccine, it was 87%, for the alpha as compared to 79% for the delta. So taking all together, this study was able to conclude that there was only a modest difference in vaccine efficacy when you compare the Delta variant and the Alpha variant, which tells us that the vaccines, that we have circulating, I mean, the ones that we use in this study that we can really talk about, are still efficacious against the Delta variant. So we don't have to have that much fear, but at least the efficacy has dropped somehow. But the overall big picture, in terms of, preventing mortality, severe disease, and all the like, is still good when it comes to that. So please, let's get vaccinated, because the vaccines will still help. Now, the effect of vaccination on viral load and transmission. Previously in one of my first slides, I mentioned from one of those studies that the viral load, in people that were infected with Delta variant was like 1,000 times higher as compared to the viral load in those that were infected with the Alpha variant. But now let's look at those that were actually vaccinated. So these are people that took the vaccines and they had breakthrough infections. And when they did the PCR, they realized that it was a Delta variant. So if you look at these two figures here, so you have fully vaccinated, no, and yes. So we are comparing, those that were fully vaccinated to those that were not vaccinated at all. And here we are looking at the CT value. Again, there's an inverse relationship between the CT value and the viral load. The higher the CT value, the lower the viral load, and the lower the CT value, the higher the viral load. And what you can see is that if you look at the p-value, there was really no significant difference. There was no difference in the viral load when you are comparing unvaccinated individuals to those that had vaccine breakthrough infections, which was really, really concerning when this publication came out. So was it like, the vaccines are not really, effective and all the like? But, as Elvis said, what's the bigger picture here? The bigger picture is to prevent severe disease and also prevent death. So the fact that you have a higher viral load, especially at the start of the infection, doesn't mean that it carries through, throughout the infection. And individuals with vaccine breakthrough infections frequently tested positive with viral load that is consistent with the ability to shed, virus infection. Now, why do we say the viral load is consistent with the ability to shed viral infections? If you look at the CT value for most of those that had vaccine breakthrough infections, it was less than 30. Less than 30 means that these people are carrying a lot of virus. So it means that even though you've been vaccinated and you've received your 2 doses of the vaccine, you can still be infected with the Delta variant, and you carry enough virus that will permit you transmit it to another person. Because, we've always been talking about, getting a vaccine and, the ability for somebody to transmit the virus when you've been vaccinated. These vaccines, as we keep saying, were really designed to prevent, a severe disease, not necessarily prevent transmission. So you could still be vaccinated, you carry enough virus in such a way that you can transmit it to another person. So if we take all this together, even though these results are preliminary, it suggests that if a vaccinated individual becomes infected with the Delta variant, there may be a source of SARS-CoV-2 transmission to others. But then, you know, when I saw this publication, this one I'm showing you now, it was kind of reassuring. So here, they look at decline in viral load during the course of illness. So as you can see, those in red, they are unvaccinated, and those in green, these are the vaccine breakthrough cases. So vaccine breakthrough, again, meaning that I took the vaccine, but I became infected with the Delta variant. So what you see is that for the unvaccinated and vaccinated, they all start off with a very high viral load. So those that, you know, received the vaccine and later on got infected with the Delta variant, as compared to those that did not receive the vaccine and got infected with the Delta variant, they all started with the same high viral load. But the good thing is that those that received the vaccine, there was a sharp drop in the viral load as compared to those that were unvaccinated. So this was very reassuring, and this can kind of explain a lot of things when it comes to severe disease, you know, and all the like that, you know. Hey, you know, somebody becomes infected with Delta variant, viral load is low, but then because that person has been vaccinated, the immune system kicks in, you know, and kinds of, you know, neutralize that virus, fight it, and you have this sharp decrease in viral load. So vaccination is associated with a faster decline in viral load RNA when it comes to the Delta variant. Now, what's the effect of vaccination on severe COVID-19 disease? So here, they're looking at disease outcome between those that were unvaccinated as compared to those that were vaccinated and they were infected with the Delta variant. So these are two groups of people. Now, these are the various disease outcome, and the clinicians will better appreciate it. You know, one of those things for those that are infected with COVID is pneumonia, and some of them will require supplementary oxygen. Some of them will require ICU admission, some will require intubation, and some will require treatment, and some will die. So comparing unvaccinated and vaccinated individuals is very, very important with respect to the Delta variant. So what did they find out? If you're unvaccinated and you're infected with the Delta variant, in this group of people, 53% of them had pneumonia, as compared to just 21% of those that were vaccinated. So it shows that the vaccine is really helping in terms of, you know, trying to prevent the severe disease from occurring. Then those that required supplementary oxygen, you see that those that were unvaccinated, 20% of them required supplementary oxygen, as compared to just 2.8% of those that were vaccinated and infected with the Delta variant. And most importantly, ICU admission. If you look at those that were vaccinated, 5.4% of them required ICU vaccination, and nobody, right, that was vaccinated when was admitted in the ICU. So this is really reassuring that the vaccines are working against the other variants, and most importantly too, the vaccines are working against the Delta variant in preventing severe disease. And of course, intubation, if you're not admitted into the ICU, I think the clinicians will agree with me that you probably don't need intubation. So that's why it is 0 here. But most importantly, mortality. If you look at those that were unvaccinated, 1.5% of them died, as compared to those that were vaccinated where nobody died. So altogether, it shows that here they use the mRNA vaccine. So it shows that the mRNA vaccines are highly effective at preventing symptomatic and severe COVID-19 disease associated with the Delta variant. So lately, there've been a lot of buzz in the news too regarding the efficacy of a third dose of the COVID-19 vaccine. I just thought I should throw this in. It doesn't have much to do with the Delta variant. But of course, at some point, we may be required to take a third dose based on this data that we are seeing. But this study was focused just, you know, in immunocompromised individuals, for example, transplant recipients and all the like. So this is an antibody titer against the receptor binding domain. If you look at those that received the third dose here of the mRNA 1273, if you look at it, was extremely very high as compared to those that received just the placebo. And here, this is the best way to actually look at it. That is some B of the figure that is to my left. So this is comparing the before and the after. So they took your antibody, measurement before they gave you the third dose and after they gave you the third dose. What you want to see is this spike, right? So if you look at each individual, there is that increase, in total antibody, before as compared to after as compared to the before. And if you look at the placebo, most of it just plateaus, right? It's just like that. So there was no change because they received the placebo. But most importantly, too, if you look at the figure to my right, so now they are looking at the prevalence, of antibodies in people before the first dose. So before you receive your first dose, of course, we don't expect, you to have COVID antibodies unless you've been infected. But all those people were removed from the study. So before they received the first dose, the prevalence was 0. After the second dose, you see that the prevalence of antibody begins to come up. Then before the third dose, it means that between the second dose and the third dose, you can look at the prevalence is getting high to that was about 40%. Then 1 month after the third dose, you see that it shoots up to about 70%. And here at B, they're just looking at the antibody titer. If you look at before the first dose, you see that's extremely very low. You don't expect to see anything there before the second dose. So what you appreciate is that after the third dose, you see, this bump in terms of antibody titer, which really, concludes that, especially in these immunocompromised people, a third dose is very, very important for them. And we don't know when it comes to other people that are not immunocompromised if this recommendation will be made as well. It just depends on studies and after some time doing antibody measurements to see if it's still efficacious against the virus. So I know it's been a lot of information, a lot of studies being presented, but what's the take home? So one of the first things, in one of my slides I mentioned is that the Delta variant is 40 to 60% more transmissible as compared to the Alpha variant. So that is concerning. And viral load for people that are infected with the Delta variant is 1,000 times higher as compared to other variants. And if you compare to the original COVID strain, and adjusted elevation in risks associated with the Delta variant is 108% for hospitalization and 234% for ICU admission and 132% for death. As I said, this is just one study, right? We cannot generalize it, but it's telling us something in terms of disease severity. And also, we've appreciated from the studies, that I presented that vaccine and convalescent sera, they show a reduced neutralization to the Delta variant when compared to the other variants. And another take home is that, they only saw modest differences in vaccine effectiveness when looking at the Delta variants as compared to the Alpha variant after receipt of the two vaccine doses, which tells us that at least the vaccines are still effective. And there was really no difference in viral load when you compare unvaccinated individuals as compared to those that have breakthrough infection. But we also appreciated that even though there was no difference in viral load, vaccination is associated with a faster decline in viral RNA, which is what you really want to see because the immune system kicks in. And also from the studies, we've seen that messenger RNA vaccines are highly effective in preventing symptomatic and severe COVID-19 associated with the Delta variant infection. So to conclude, the title of the presentation is How Dangerous, is the Delta variant. So without a doubt, increased transmission, coupled with the potential of increased disease severity and immune escape actually makes Delta variant especially dangerous. But the good thing is that the vaccines are highly effective at preventing symptomatic and severe COVID-19 that is associated with the Alpha variant, the Delta variant infection. So thank you guys so much for your kind attention. I decided to try to make it brief so we can have some time for question and answers. As I said, COVID is a very, very big thing. No one person knows it all. So I'll just open it up now for us to have a discussion. Thank you.
Oh, thank you so much, Kenji. Thank you so much for this excellent presentation. I mean, I've learned more about the Delta variant than I thought I knew. And so this is really surely a very wonderful session. And I'm sure many people in the audience would have, shared a similar experience like me. Thank you so much for taking time to put together this very important updates on the Delta variant and how dangerous it is. You might want to stop sharing your slides so I can get the faces of those who
Yes.
are anxious to start asking questions. And Christelle, what
Oui,
can you say
Elvis,
about the presentation?
c'était très magnifique, c'était très intéressant. J'ai appris beaucoup de choses, beaucoup. Et je crois que tout le monde aussi, chacun, vraiment des questions de l'heure, comment ça se passe, d'où viennent les variants, comment ça se transmet, quel est l'effet par rapport à la mortalité et bien d'autres. Merci beaucoup, Dr. Kenji.
Thank you so much. And I think, we will be throwing the microphone to the audience to get your questions. I know there are people already indicating that they have questions. And before I turn over to the audience, Kenji, we cannot attribute any particular cause to the mutation because it is the natural behavior of virus that they do mutate, correct?
Yes.
And
Also, it really depends too, if you look at the spike protein, it's always under selective pressure. So like once it gets, that's what is exposed to the human body, the antibodies target it, the medications target it. So viruses are also smart. As you try to target them, they'll also look for ways to evade that target.
Which means that as long as we don't deal with the COVID-19 virus as fast as possible, we will be expecting more mutations, correct?
That's correct. Before now, probably about 6 or 8 weeks ago, we're only talking about the Alpha variant, right? Because, probably people didn't get vaccinated and all, we didn't reach out to me. As long as the virus is replicating, it's going to mutate. That's how Delta variant now came. And now we are talking about Delta plus. So as long as it is replicating, something's going to pop up.
And in the history of viruses that has there been any virus that has mutated this fast and this many within a considerably relatively short time?
Viruses will mutate all the time. A lot of viruses, as even we are talking now, the flu is mutating. You have antigenic shift. But the thing is, what is the importance of that mutation and where is that mutation occurring? So it's not just a mutation happening, but it's what does the mutation do to the virus? Now we are beginning to appreciate, especially for COVID, especially at the level of the spike protein, that some of these mutations are very, very important for the virus to be more transmissible, for it to evade the monoclonal antibodies and the immune response that have already been directed to the virus. So viruses will continue to mutate. But the thing is, the COVID-19 virus is not mutating as fast as compared to the flu, for example. Right? So if you take the flu, it's mutating faster as compared to SARS-CoV-2. But the difference here is that the type of mutation and where that mutation is occurring and what phenotype it gives to that virus, that is what makes a huge difference here.
It means we have a long battle to fight ahead of us. Christelle, vous avez la question pour Kenji?
Oui, j'ai une question très pertinente pour moi, notamment sur la fin de la présentation. Je vois que de plus en plus, la troisième dose vient en surface. Déjà qu'on n'a pas pu vacciner avec la première et la deuxième dose. Et maintenant, vous dites que la troisième dose permet de réduire les variants. Donc, je me demande où est-ce qu'on va? Il y aura une quatrième dose? Il y aura une cinquième dose? Parce que la troisième dose n'atteint pas 80% de protection. C'est quoi la suite? Je ne comprends pas.
Yeah, those are things that we cannot really predict if we are going to have, a fourth dose or a fifth dose. For now, the third dose is recommended for, immunocompromised individuals, because even there at Stanford, we had to develop a new assay just to look at these immunocompromised individuals. Do they even have antibodies, against COVID, even though they've been vaccinated. And you look at all those measurements, the antibody titer is very low because, of course, they're immunocompromised. So in this selective class of people, you may want to treat them separately, in terms of giving a third dose. And studies have shown that that third dose actually allows them to mount, a higher immune response and all the like. Now, when it comes to those that are not immunocompromised, I've taken 2 doses of the virus. Now, are we going to need a third dose at some point? What we're beginning to see is that as new variants begin to pop up, you look at the neutralization potential just for the Delta variant, it drops, right? Because where the mutation is taking place really matters. So with respect to the Delta variant, I think for now, the vaccines that we have and the 2 doses, but then we don't know if another variant is going to pop up tomorrow that is going to be more stubborn or more resistant when it comes to neutralization. If it becomes more resistant, we may get a booster dose. And the booster dose may be directed to that particular variant, or it may just be something that's general. For now, it's difficult to predict. But we have that power and we have that opportunity to prevent this from happening. And one of the ways that we can do is follow the guidelines, wear a mask, where it is recommended, take vaccines, get vaccinated. Imagine if a lot of us, 90%, 80%, of the people in the country are vaccinated, we'll be able to try to, to stop transmission and prevent the virus from mutating. So now it's very premature to say if we're going to need a 4th dose or not. And I understand your concern. Some people have not been able to take the 1st or the 2nd dose. Now we are talking about the 3rd dose. But one thing too, in vaccinology, you really don't need to have everybody vaccinated. As long as you're able to vaccinate a certain proportion of the population, we can then achieve herd immunity.
Thank you so much. If you want to ask a question, you can use the button to raise your hand up so we can know that you have a question. I think before I call, we had Bama. Bama's hand was up. I don't know if Bama is still available to ask his question. I see Kenji's hand is up. There's Kenji, you want to ask your question?
Hi, everyone. Kenji, thank you for the presentation. It's actually a nice one. I appreciate it. So I have a series of questions for you. There are about 3 questions. I hope the host will permit that. So my first question is, I know you never mentioned this, it goes a bit into the hematology part of it. Of recent with these vaccines, we've had a lot of deaths due to clotting, blood clotting around the system. Has any mechanism been proven? Because looking at the vaccine, we know generally there are things like dendritic cells, which can pick up some of these pathogens or whatsoever that comes into the body, drives it maybe at the level of the spleen where you meet all these macrophages that will then do whatsoever. And so I don't know, has looking at this pathway, have you guys or has any mechanism been concretely proven at this level? That's the first thing.
The first question, I will direct it to our expert, Dr. Fuma, who I think he should be able to help with the first one.
Okay, then the second one, I would like to know because just as Crystal mentioned, over time, we are talking about the 2nd, the 3rd dose now, and the 4th dose, maybe the 5th dose, etc. Has it been proven that with any of these vaccines, there is waning immunity or the vaccine wanes over time? And therefore, if it wanes over time, means do we need later on to consider maybe, I don't know, this pathogen or virus to be some sort of flu that we need shots every year as they do in the Western world? And the 3rd question is just to know, because I'm not a specialist in this, I'm into immunology, but not into immunovirology. So I would like to know what actually are the neutralizing antibody at this stage, because you mentioned about this neutralization assay and everything, but what precisely are the neutralizing antibodies against this virus for now? Thank you.
So maybe just stay on the line. I want to get your second question. Can you take that again, please? Sorry, I didn't write that down. Hello, I think you're on mute.
So the second question was about waning immunity, and the
Okay.
third question is about neutralization antibodies.
Okay.
Are there specific neutralization antibodies for this,
Okay.
or I don't know?
All right, starting with your second question regarding waning immunity. I mean, we've already appreciated it that when it comes to the vaccines, and if you look at the data that I've showed, it shows that it kind of wanes. And we have to be careful when we talk about waning here, is with respect to, if you take like the original COVID virus itself, we see that, I mean, the neutralization potential is still high when it comes to those. But these other variants that develop, you see that the neutralization actually drops. So if you take all the picture joined together, something is waning down gradually. And that is why we may need a booster because of all these new variants that are popping up and all the like. So that's why we may be needing a booster at a certain time. Then is it going to be something like the flu? I'm sure you asked something like that. Is it going to be something that we may be needing a vaccine every year? For now, it's difficult to say if we'll be needing, a booster every year. One thing with the flu is that you understand that it is segmented RNA. So you have all this antigenic shift and drift that occurs all the time. That is why, every year you have to come out with a new, a different vaccine. You have to get a new flu shot because of that. And the rate at which mutation occurs in influenza is way higher as compared to the rate at which mutation occurs in SARS-CoV-2. So we may not anticipate getting it every year, but it is still premature to make that kind of conclusion because with COVID, things happen all the time. Yeah, so that's what I would say with respect to that question. Then tell you in terms of neutralization, most of these studies are laboratory studies. So what they do is they produce a pseudovirus. So it's not actually the real virus, right? So you can produce this recombinantly. And most of the antibodies are targeted against the spike protein. So you're trying to neutralize the spike protein that's found on the pseudovirus. So you have all the pseudovirus neutralization assays that has been done in the laboratory. So that's why, I always say that there is always a distinction between what you see in the lab and what you see in real life. So the fact that you have a decrease in neutralization potential in the laboratory doesn't necessarily mean that that's what you're going to see in the real life, because it's not all about neutralization, right? You have the humoral arm of the immune system, same as you also have the cellular arm of the immune system. So you may have probably a 5% drop in neutralization, but that's not sufficient enough to make the vaccine less efficacious, because as of now, we don't know the correlates of protection. If we knew the correlates of protection, we'll be able to say that, hey, all right, this drop in neutralization potential can probably mean that the vaccine is no longer efficacious. But for now, we don't know the correlates of protection when it comes to SARS-CoV-2.
So if I may just try to be clear, because in one of your slides, you actually show where they use the AstraZeneca and the Pfizer vaccine, and they tried to use this serum, and we know obviously in the serum you have these antibodies. Mm-hmm. So was this study using this complex matrix of antibodies within the serum, or they actually did some, I don't know, isolation specific antibodies?
No, they didn't isolate any specific, and I know what you're talking about. They didn't isolate any specific antibody from the serum sample. So they used the crude serum sample the way it is. And you understand that from mRNA, what it really wants to do is to produce antibodies against the spike protein. So that's what you expect to find in the serum sample of those individuals. So they didn't isolate specific, antibodies from that serum sample. They took it the way it is, and they look at its ability to neutralize the pseudovirus in the laboratory.
Thank you so much.
You're welcome.
Dr. Muno, you can answer his first question if...
Yeah, so it's one of those questions. One thing I want to say is that it's not very common, despite the hype that came in initially for vaccine-induced immune thrombocytopenia. So there are two different mechanisms, things that could be going on. There is something called ITP, which is idiopathic induced thrombocytopenia, which we see that a lot. The body is actually destroying platelets. So your immune system has been primed and the body is destroying platelets for some reason. We have seen that already in so many vaccines. Because you're stimulating the immune system, you're making antibodies, IgGs, and they are targeting the platelets and destroying platelets. Our platelets are very vulnerable. This is one of the things I do a lot, but we have never in the history of mankind gotten to a point where we are vaccinating 6 billion people at the same time. This is an extreme high number of people we're vaccinating at the same time. Then you get to pick up certain side effects, which could be relatively very low, but the number becomes outstanding because we're giving 6 billion doses. And it looks like we're getting this everywhere. It was blown up in the media also, but what we are seeing in real life is that it's very low. The prevalence is really, really very low. And there are two things, as I said, there is the ITP branch of it, and there is something called the VIP, which is vaccine-induced, which is looking like what we call heparin-induced thrombocytopenia, which they're making IgGs against something called TF4, which is just an antibody found at the level of the platelets. So that is really what is happening here. It's an autoimmune kind of process where your body is destroying platelets because you have boosted the immune system, and the immune system has created antibodies that are targeting platelets. So we see this with AstraZeneca, we see this with Johnson & Johnson a lot more. We see ITP with all vaccines, but also getting the adenovirus component. Most adenoviruses, we have seen this with them. They were pretty low because we've been using this in vaccinating 1 million people at a certain time. But now we're vaccinating 7 billion people. We have given out about 7 billion doses. So we get to see the side effects, and it looks like it's something new. It's not new in terms of vaccinology. It's something that has been existing. And we just need to be able to identify it quickly and get to treat it as quickly as possible. The treatment, if you identify it rapidly, is kind of using anticoagulants other than heparin. We can use something called the Nuvo anticoagulants, which is apixaban, Xarelto. There is also agatroban, which is the main treatment which we get to use in this patient. So this is being monitored. If you're in any area where you're vaccinating a lot of people, you should be looking for these signs and symptoms, getting your hematologists and those who are frontline healthcare workers alert about this, that it can occur, but it's pretty low. So in terms of this, it's still very safe to get these vaccines. And we're trying, it's showing us that the system is really working. If we're able to pick these rare side effects that occur, in real life, you could do clinical trials in 1,000 people. But the real deal is the real life thing. We've given 7 billion doses, so we're able to see even the rarest of rarest side effects. We're picking them up now because we're just giving a lot of vaccines out there. So better get vaccinated. I would always say that to my patients. You are not going to be, it's very rare that you're going to be the one developing this rare side effects. Get the vaccine, and it's better to be vaccinated than to be sick. That I can assure you.
So
can we,
Dr. Foma, if I add to that, you know,
Yes.
just still putting you on the spot there. You know, one thing when people hear about this clotting, you know, some of them will say, hey, I don't want to take the vaccine because I may suffer from this clotting. Can you comment on the probability of having this clotting due to COVID itself as compared to having it from the vaccine?
So the probability of having this due to COVID itself is higher than getting it from the vaccine. That's very important to put. That's why I say everything should be put in context. Yeah. So we've had many medications that do cause clots, but no one has spoken about them. COVID itself is more than 100 times more likely to give you a clot from getting COVID than from getting the vaccines, which are adenovaccine derivatives. Mm-hmm. Getting oral contraceptives, just being on oral contraceptives, is almost 8 times more likely to cause you a clot than even the COVID vaccine. Just being so there's just so many factors that if you put things in context, people get to see the risk. But each time people don't see things in context, people get to misinterpret it and really run with the idea that we are vaccinated. Just take, for example, in New York, we're vaccinated, we're given millions of doses. How many cases are we reported? It really counts, but by giving just oral contraceptives, I find my patients in the clinic every day who come to my hematology clinic with clots. Really, just those who are on oral contraceptives get clots. And we try as much as possible to avoid giving it in certain women. So I'm not trying to say oral contraceptives are not good. It's just telling you that putting everything, as Kenji said, and COVID, every COVID patients, if you look for a clot, you're going to find a clot somewhere. That's why part of the treatment is anticoagulating them in those who have mild cases, not those who have severe cases who have not seen any difference. So part of the treatment protocol is actually giving them anticoagulation because these people are rapidly forming clots.
Great.
Okay, thank you.
Thank you very much, Kenji and Muno, for answering his questions. We'll call on Gilbert Banga for to ask his question before we get to Diodone and Crispo, then Dr. Kate.
Before the next question, can I just throw a little bit light on what Dr. Foreman said? Is Brown?
Oh yeah, Dr. Brownhill, yes.
Yes, sorry, I can't show my face today. I just finished a 19-day stretch, so I'm trying to rest. Yeah. So you know, I followed a little bit of what Dr. Kenji said, like really at the end of it. I joined late. So yeah, the clotting. I'm very with you, Dr. Former, about the risk of clotting from the virus itself is way more than the vaccine. In fact, I just finished ICU last week, and I'll give you just two scenarios. There's a 35-year-old guy that I got in ICU, morbidly obese, no other medical problem. Came in, COVID, was on the regular medical floor, and then suddenly around like midnight, developed sudden respiratory distress, developed a STEMI, ST elevation MI. They had to rush him to cardiac cath lab. Interventional guy did cardiac cath on him. He had a large thrombus, large in the RCA. They, and the guy, they tried to lyse it and, then send him to ICU, intubated, obviously. And he was bradycardic. We almost put a pacemaker in it, transvenous, had to start on dopamine. Guy went through hell. I had another 52-year-old who actually had COVID, mild symptoms. His wife had COVID, so he went and tested. They said, well, come back in 5 days because he was negative. Tested again by the 5th day. He was positive. He was having just fatigue and loss of smell, loss of taste. After about 7 days, he was cleared to go back to work because he had mild symptoms. He went back to work, started having shortness of breath. Turns out the guy had a big, massive pulmonary embolism, saddle emboli, to the point where they had to do, interventional cardiologists had to do echos, which is, they use a catheter, they do thrombolytic therapy with a catheter, using a catheter. And they had to take this guy to the lab twice, 3 times actually, just trying to break up the clots. So eventually, they both did okay. But this is just to tell you how, even with the vaccine itself, the virus itself, and these are patients, these 2 patients I just mentioned are relatively young. And the second guy, the 52-year-old, had diabetes, but they didn't really have any medical problems. Now, on the contrary, I had an 82-year-old who came in, just to tell you how the power of the vaccine. She had been vaccinated with Moderna vaccine, and the last shot was 2 months ago. Doing perfectly fine, 1 month ago, sorry. Doing perfectly fine, woke up in the morning, called the children that she can't breathe. Now, this lady has a history of congestive heart failure. Ejection fraction is 20% only. Stage 3 kidney disease. History of ovarian cancer years ago. And she's 82 years old. And so by the time EMS arrived in the emergency room, she was hypoxic in the 60s and 70s, in respiratory distress. They intubated her, then flew her to our hospital because she was like 2 hours away. So this lady came in. Within 24 hours, I extubated her. She did that well because, she was vaccinated. I didn't know what direction, if she was going to make it, given that she had all these comorbidities. And when her children came and I put them at the door, just after vaccination, that 82-year-old looked at them, threw kisses, gave them a thumbs up, almost like a victory lap. And within 48 hours, she was out of ICU. She's home now on room air. So within 5 days, she was intubated, and back home on room air. Why? Because of the vaccine. So, irrespective of, yes, it is true that the Delta variant is a little bit more transmissible. And we have some, I have an ICU staff who was vaccinated, who also just had COVID. And most likely she has headache, everything that you suspect that is the Delta variant. So it is still absolutely necessary and important to vaccinate, because even with the vaccination, even when you get infected as a vaccinated person, you have a better chance compared to someone that's not vaccinated. So thank you.
Thank you so much, Dr. Brahmhida, for bringing the real life situation. I mean, you experience this every day. As, we're really glad, and your words are inspiring to those who are not yet vaccinated, who are still thinking that get vaccinated. That's the only way forward. So thank you so much. And Muna, once again, thank you for answering the questions together with Kenji. So now, Gilbert Banga, we want to get your question. Possible.
All right. Thank you, everyone. And thank you, Dr. Kenji, for the insight presentation. I really appreciate your knowledge and background on this. I do have 2 questions that probably can be summarized into one, but I just wanted to find out.
Sorry, can you tell us, just always situate us where you're calling from and what you do, just so we can always know,
Okay, sorry. My name is Gilbert Banger. I'm calling from Buffalo, New York. I practice with a Maplegate anesthesiologist company here in Western New York, and I'm from Cameroon.
Go ahead with your question. Thank you so much.
Okay, thank you so much. So my question, the first question is actually about the virus mutation. So is there any data that can show if the mutation is actually because of the vaccine or the different types of vaccines, and if there's data, which one of the vaccine is actually responsible for the mutation? And my second question will be, I know we've been talking about the breakthrough infection for people who've been vaccinated. Is there also any data that shows, depending on what type of vaccine that you get, has there been any numbers that shows that people who've taken this vaccine tends to be reinfected more than people who've taken this vaccine?
All right, thank you. Those are very great questions. So let me just start from the last one, because I didn't have time to write it down. So we are looking at breakthrough infections. Then we are comparing different vaccines. I think Dr. Foma has always made this comment that you look at countries that have been vaccinated. You have some countries that about 80% of the people have been vaccinated, but they're still coming a lot with breakthrough infections. So it really depends on which vaccine you are using. Not all vaccines are created equally, right? But the good thing is that all of them will try to help in terms of preventing, severe disease and all that. We've come to appreciate that the messenger RNA vaccines are doing better as compared to the adenovirus vaccine. So if you look at studies in terms of breakthrough infections, we are seeing more in those that took the adenovirus vaccine as compared to those that took the messenger RNA vaccine. Now, there are other vaccines that we are not so familiar with because there's not a lot of data on it, like the Sino, vaccine and all those things. But just from, the adenovirus vector vaccine and the messenger RNA vector vaccine, we've learned a lot. And of course, if you just go back to the clinical trial data, that's where we can even start from. If you look at the messenger RNA, vaccine, is about 95% in terms of the efficacy. Then if you go now to the adenovirus-based vaccine, Dr. Fuma, correct me, I'm sure it's about in the 80s or late 70s, like that. So just by starting there, the efficacy are not all the same. So you'll definitely be seeing more vaccine breakthrough cases in those ones that are less efficacious as compared to one that has a higher efficacy. But the most important thing is that it shouldn't stop anybody from taking the vaccine, because even if you have a breakthrough infection, as you've heard from Dr. Brahmhida, it can help prevent you from coming up with severe disease. It can also reduce the length of time that you spend in the ICU just because you were already vaccinated. Then mutations. So you're asking if the mutation is because of the vaccine. Now, if the mutation was all because of the vaccine, then those that were unvaccinated, you will not expect them probably to carry such mutation. So it's not all about the vaccine. It's not the vaccine that is driving the mutation. Messenger RNA in biology, when it comes to replication, there's always an error that occurs when replication is happening. So it's not all about the vaccine. Is the biology of the virus itself. When it's replicating, errors occur, and those errors, they begin to accumulate over time. One clear example is, take like bats, for example. I'm not sure bats have any vaccines against COVID. But if you look at the evolution of the coronavirus in bats themselves, you see that it has mutated over several times. It comes to a level where it's able now to, I think we're having some interference, able now to infect humans. So viruses on their own, once we propagate them in the lab, just take, for example, laboratory experiments where we take a virus and we grow it in the lab. If you look at it, you can start seeing some of those errors that occur. So viruses on their own will mutate without a vaccine. Now, what probably we may be talking about is maybe what is called selective pressure. Now, when there is a selective pressure that is driven towards a particular antigenic recognition region of the virus may try to tweak it in such a way that it can evade it. We've seen this with monoclonal antibodies. We've seen it with antivirals for HIV and all those things. So you can have what is called selective pressure that is directed towards a specific region of the virus that can, help it mutate as well. So, yeah, so that's what I'll comment on the first two questions. I don't know if I answered your questions.
So, yeah, just adding that there are some, let me share you some studies which they're interesting, but it's just adding to what Kenji just said, that we do have some studies out there. This is just things I've been posting sometimes online, so you would get to see me do this all the time. So you see here, this is a comparison between the different variants. You see the studies that were published in New England Journal for the Delta variant, they have been very variable. And as Dr. Kenji said, you look at the AstraZeneca is always lower than the mRNA vaccines. But there was this Mayo Clinic controversial study that showed that Moderna was 76% and Pfizer was 42%. I think that may be what you're referring to. And there is this other Qatar study. But the time of vaccination in the critics, because most of the time Moderna was given later than Pfizer. So is it that the vaccines have been weighing off over time? Or is it really that Moderna is better than Pfizer? There's no reason why it should be. So this is really most of what we are seeing is that the mRNA virus vaccines are actually better than the other vaccines, but all of them do prevent death, which is the most important factor we are looking at. Elvis, you're muted.
Thank you for answering the question, and thank you so much, Gilbert, for your participation. So we call on Dr. Is it? We have Jordan Ekum, please.
Hi guys, can you hear me?
Yes, we can hear you.
Okay. My name is Jordan Ekum. I'm a virologist from Belgium, but I'm currently in California. I was invited here by Kenji. So nice to meet all these faces and the work you guys have been doing. I have some questions. We've been talking about antibodies, and rarely do we hear about T cells. And as Kenji mentioned, there are two arms of the immune system. We have the humoral system, and we also have the cellular system. We know that with malaria vaccines, we face a lot of problems because we generate antibodies, but these antibodies are not that potent. We need another arm of the immune system to help. And that's why we also have to target components of the cellular immune system so that they can work together to eradicate this. For COVID, since the beginning, we've been hearing about antibodies, and I would like to know the role of T cells. We know that if you use convalescent serum, that is, if you take someone who has been exposed, and these guys surely they have antibodies, if you transfer the serum to a naive patient, the patient somehow you get the efficacy, but it's not that robust, right? If you also look at the types of vaccines, if you take the mRNA vaccines, so these contain the whole genome, you get more epitopes of the virus compared to subunit vaccine, where you get only part of the genome. So in this case, you get fewer epitopes. And this suggests that T cells might kind of play, not might, although it is not confirmative, affirmative rather, T cells might play a role, but we somehow neglect the importance of T cells. And this might help us to rationally design this vaccine so as to get higher efficacies. Probably that also explains why the mRNA vaccines outperform these other vaccines, because you have a whole genome that's been introduced into a system, and in that case, you get more epitopes to mount a solid and robust immune system. So I would like to know the role of the T cell in these pandemic, or whether or not there are labs working on these to address or at least refine these vaccines so that we can get 2 arms of immune system that we better do the job.
All right, thank you so much. That's a very fantastic question. I wish my co-presenter Brian was here. He's a T-cell person and has a lot more knowledge on T-cells as compared to me. Yeah, I will agree that most of the data has been biased more towards the antibody response. One thing too, you're a researcher like me, dealing with antibodies is much easier. Designing experiments when you have to look at antibodies as compared to when you have to look at T cells. But the role of T cells, you know, in the fight against the virus cannot be underestimated. Studies have shown this. I'll just give you an example of some cases. We have people, you know, that come to the lab, you test them for antibodies and they don't have any antibodies at all, but they have been infected with COVID. They didn't produce any antibodies. Then what we did is we now collected whole blood from them. Then we did the interferon gamma release assay. And the interferon gamma release assay has to do more with the T cells. And you see this spike in terms of interferon gamma release. So it shows that T cells play a vital role in terms of the fight against COVID. Now, if it was all about antibodies, look at the reduction in neutralization potential that we've seen in all these studies. So it was all about antibodies, then the data shows that the vaccines probably will not really be efficacious again. That's why throughout my presentation, I was saying that even though there's this reduction in terms of efficacy, if you look at it in real life, I'm sorry, if there's this reduction in terms of neutralization, if you look at it in real life, the vaccines are still efficacious, meaning that it's not all about the antibodies. The T cells have a great role to play. And I think Dr. Foma is sharing a study on T cells.
Yes, Dr. Mono, you want to come in?
You're muted.
Yeah, this is a very important, as Kenji said, research. And I think, Diodene, you're a researcher, and I think a lot of researchers are concentrating on this. I know this very well. There are guys in NIH who are really concentrating on figuring out the place of the T cell. You know, you're better placed than me to know it's a very difficult research to carry out. But there are several researchers who think that the T cell plays a major role. Like we do know, MHC class 1 and class 2, we know in viral infections, MHC class 1 is extremely important. And this is all T cell run. So everyone who is an immunologist knows this, and they believe it's just that it's difficult for them to do this. But this study here, which shows the impact of mRNA vaccine, the second dose and the third dose, this actually shows how T cells are impacted by these different vaccines. And there are several other studies that I can share, which I'm also very interested in it, but I'm not an expert in the field of T cells. But I know some researchers who are working on this, especially with cancer patients, also to see patients that we have certain patients, we're putting them on the rituximab. Those are all CD20 inhibitors. And they're trying to see how this affects the amount of the B cell arm and the T cell arm. If the T cell arm is still able to mount an immune response once you're in the B cell arm of the immune system. So this is really a field where we're going to learn a lot more. And I would actually encourage you to jump in the boat for this kind of research. And I think it's a favorable place where we can get a lot of data.
And I will just come in very briefly, guys. I would like to say in my laboratory, in Australia, we actually worked with the natural killer cells on this COVID, which is quite a challenge. So, but same like with the T cells, now it's being shifted from the innate to the adaptive arm and linking more to the adaptive immune system. So most of the things or the work done on T cells are also reflected on natural killer cells. So Dieudonné, if you're interested, I can share some of the data with you later on.
Yeah, sure. If you permit, Elvis, can I ask one more question? It seems we are, I think, predominantly from Cameroon.
Christelle, should he ask one question?
Yeah. Yes, please
Okay.
ask your question.
Yes, sorry. Yeah, since we are from Cameroon, we've had this question and a lot of conspiracies. We know the prevalence is different here in the Western world compared to what we see in Africa and precisely in Cameroon. I want to know what accounts for this. I know there are some, it's difficult to to convince someone, but since we are in a panel like this, maybe we can contribute ideas, right? Someone will tell you, yeah, there is no COVID here in Cameroon, people don't go to the hospital, but I believe maybe it is more asymptomatic in Cameroon. So it is true that we do not get like the death rate we see in Western world, but it is still there in Cameroon. We don't just want to admit because we don't see people dying as you would see here in the US. You see people filling up hospitals, but that's not necessarily what we see in Cameroon. So we want to know what contributes to these differences.
That's a very fantastic question. 3 weeks ago, I was just discussing with Professor Leke this same question. We said it's a $1 million, question to answer. Somebody that unwraps this this mystery should probably win a Nobel Prize. So that there are a lot of things, that can attribute, and I'm sure we've discussed this several times in the town hall. Looking at our population age group, right? You are in the West, you see that we have, when the pandemic started, or in general, we have older people here in the Western world, and you will have a lot of people that are old with pre-existing conditions, and those pre-existing conditions are well managed. Somebody with diabetes here, they'll manage that diabetes, so the person will continue to live normally with the diabetes. Same with hypertension, same with all those things. But if you look at our age group in Cameroon, it is very, very young. I think the life expectancy of a man, correct me, I think it dropped from, was it 41 to about 38 or something like that. That's the life expectancy of a man in Cameroon, as compared to probably in the US, where you're talking about the 70s and the 80s. Now, if you look at who are those that were dying of COVID, even here in the US or even in Europe, there are mostly people aged greater than 61 years old with pre-existing conditions. So if you go to a place like Cameroon, how many of such people do we have in Cameroon in general that fit this kind of criteria, that are older and are having pre-existing condition? So that's one of the reasons that we can start attributing, for the low mortality that we didn't see. And I always want to tell people, even when I was giving a talk there, I was telling people there is a difference between, mortality and being infected. Are we saying that people are not being infected with COVID in Cameroon, or are we saying that people are not dying? If it's regarding being infected, I would say that most likely people are being infected. Now, if you don't look for something, you will not know if it is there or not. If your age group is young, it means that most people will probably have asymptomatic infections. And people who are asymptomatic infections will probably not readily go for any testing. To begin with, how many people are we testing in Cameroon and in most African countries to even say how many people are infected? PCR is not readily available wherever. So you see that even the data in terms of the number of infections in the country and all those things is really, really limited by the diagnostic capacity that we have. Now, other people have gone, to look at things like genetic factors, look at things like previous antibodies, and all the like. We just have a paper that we did. So these are samples that I collected in Cameroon in 2005. That was pre-COVID. So we're trying to see if we could find antibodies, against COVID-19. In a majority of the samples, we found antibodies against seasonal coronaviruses that were cross-reacting with our antigens that we had produced for SARS-CoV-2. So, I mean, does that cross-reactivity translate to neutralization? That's the next phase of the study that I want to do for those Cameroonian samples, to see if those serum samples are able to neutralize the pseudovirus. Then we can start making some kind of, assumption. But till then, looking at the immunology, I'm not sure we have a clear explanation to that. Now, moving forward, as I said, seasonal coronaviruses are not only present in Cameroon. So even here in the US, we've tested our US samples. You see that almost 70% of people in the United States carry antibodies against seasonal coronaviruses. So if you make that comparison, it may not really hold strong. I mean, we are just hoping that we'll see something for neutralization, but it may not really hold strong because seasonal coronaviruses are everywhere. It's not only in Cameroon. So one of those leading things is first our age group, and the infection is probably higher. The prevalence is probably higher than what has been reported. Seriously, in Cameroon, nobody considered that there's COVID, right? Putting on mask, I was there recently. You put on mask, I think I was like the only person on the street, and I felt so embarrassed, and I had to take it off because it shows that it's a novice in town. Right. So it's like business as usual, but we are just grateful that even though it's business as usual, we are probably not see a lot of people that are dying from it, because seriously, we had that age population of it will really hit us hard because we don't have all those, facilities that will take care of. So this is an open discussion. I don't know, people too in the town hall can chip in, what they think as well.
It's a topic on its own that can take an entire town hall. So thank you so much, Diodone.
Yeah. Thank you also.
It's a topic we've tried to answer since the beginning of this pandemic. And I've done a lot of presentations talking about this topic. Kenji made the most important, which is the age disparity between the West. But there are other things like population density. There are other things like just human transaction and movement, which has been explained a lot in this pandemic. If you look at just studying the number of flights flying into Africa and other areas, you see South Africa is highly hit because South Africa has the highest number of flights, and also more development looks like a driving factor in this pandemic. It's one of the few pandemics where being developed looks like a driving factor, because if people can move around, then they can spread it. Cameroon has like 2 flights in New York every single day. In Atlanta, there are about almost 1 million people transiting around that place. So you can imagine if 1 million people are transiting around. But you ask me, what about China? Now, the problem in China is that wearing masks is mandatory. So come on, there are so many things that we have seen which are empirical, real things, live things. Movement, you will not get a case in Wa, in Yota, in Yoba, in Cameroon, or somewhere in Mada, just because no one goes to Mada, even no one even goes there. So internal movement in itself, I think this can be one of those factors that will tell you the level of development of a country is based on, I'm just saying this place, it's not based on anything. You can actually look at that to determine how much COVID spreads. The more remote the area, the less spread of COVID. The more secluded the area, nobody goes there. There's no way COVID can even penetrate and come there. So I think that's one factor that I have just been looking at. It's something to look at it. And once you start allowing movement, then you start allowing the spread of COVID, especially when people don't put on masks. That's one thing. There's also this aspect of immune priming, which we have talked about, but I don't think that's the right hypothesis. In the beginning, we spoke about the BCG being priming the immune system and the boosting the T cells and all of that, but it looks like it's not a real true hypothesis at the end of it. And Kenji talked about the hypothesis about the other variants of the other COVID, different COVID viruses that have been existing in Africa and all of that. But South Africa is really proving us wrong in terms of a lot of things. If you're really assuming, and my fear is that we are going to be the next India, meaning as much as this virus starts getting mutated, then you get yourself in a situation where we'll get a variant which is highly transmissible appear in Cameroon, and we are not ready. Or in other African countries. No one is safe from this virus. I do not really believe we have something special. trust me, I truly do not believe we are special in any way. When this started, they said Black people were not infected.
Yeah, in the US.
Then in January, February, March in New York, I saw all Blacks and Latino die in front of me. Guys who were of my age. I was so, I was in the front line, but so scared. Never had to be there, but so scared because trust me, no Black guy is protected. No one of them is. We're actually having higher risk factors and diabetes making it worse. As Kate said, in Cameroon, majority of those who died were those who were diabetic. The data they have, I think Kate is working on a data set of all COVID patients in Cameroon, and they're able to tell exactly those who died and those who stayed alive and what they have. And you can see that diabetic patients, hypertensive patients were more affected and they died more. So I think your question is $1 million question, really.
Thank you, Mono.
Thank you very much, Mr. Chairman and Dr. Kenji. Can you please ask Dr. Crespo to come in? Thank you.
Oh, thank you. Thank you, Dr. Kenji. I'd like to first of all say, I think the Black people in the US or abroad are not like the ones who live in Cameroon or in Africa, because what they eat is very different. Anyways, I just had a question. I think,
as they said, achu soup help. Are you suggesting that achu soup also help?
I'm not inferring to anything. I'm just saying that what they eat is not the same thing. The same Dr. Dewa who gets on verses and says stuff, we don't have that here. So it's really, really different. I think environment has a lot of play in it as well. But my question was, because I think today what we should try to do is try to debunk as many, lots of this fake news that we have in terms of vaccine hesitancy that goes around. And I think those in France have really been on the media, and they've been talking a lot and trying to bring a lot of controversy in terms of getting the vaccine. So one of the things that has really been, going around that I wanted Dr. Kenji to talk a little bit about it is, when we get a vaccine, right, does the vaccine go in order to, because we know that antibodies are specific because they bind to the spike protein, which are specific. And we are producing a vaccine which is helping us to produce specific antibodies as well. So the argument is that we are producing specific antibodies which bind to specific spike proteins. And then when the virus mutates, what happens is that these spike proteins change, and then our vaccine creates a pool of antibodies which saturate and prevent our normal host antibodies from actually working more. And what they say is that our normal host antibodies are more malleable, so they are more liable to, attack a foreign virus or bacteria, irrespective of actually what it is. So they are saying that the vaccine we're giving is producing a very specific immune response, which is so specific, and it's then preventing our system normally from producing its own natural antibodies, so much so that when we get a new variant, we suffer just as if we had not been vaccinated, and it makes our immune system weaker and doesn't really help us. I don't know if you can clarify a little bit.
Yeah, thanks for that. If it was that so specific as they are talking about, why is it that you look at the studies that are presented, people that were infected with the Delta variant that had taken the vaccine, they suffered less severe disease. And it's not as if everybody, you have people that took the vaccine, but they have not been infected with the Delta variant. Now, one thing we fail to understand is that the immune response that is elicited, or the antibodies that are produced after the vaccination, is not monoclonal, it is polyclonal. And that is an added advantage. Polyclonal means that if one part of that spike protein mutates, it can still neutralize it, because a polyclonal immune response is almost the same like the one that you produce during a natural infection. If it was a monoclonal response, then we'll be very worried because it is targeted just to a specific a part of it. And if it changes just a little, that is it, no neutralization. So, I've not read the details of that, but, what I can say is that the vaccines are working, even though we have the variants. That's a huge plus. And the reason that they are working, even though we have the variants, is because the immune response that it elicits, it produces polyclonal antibodies as compared to just monoclonal antibodies. And the other ones, I don't understand the full mechanism when they say that it doesn't respond and the vaccine will produce something that I didn't really follow so well. But the bigger picture, that's what I can comment.
So our immunes, this is a question that this is how those who are, they say, half book no fine, because this is how those who are poorly, it's very difficult when someone can convince you about something they don't understand because they try to make logic about it. But the immune system doesn't work like that. Do you know how many times the immune system tries to kill HIV? 1 billion times. Every infection. The immune system is so good at its job, but it fails 1 billion times just because it was designed to fail 1 billion times. Just because the HIV, I'm taking the HIV, for example, is being coded by your cells itself, the outer shell. So it's difficult for the immune system to see this virus in the whole. Viruses have become intelligent as much as the immune system. So the immune system learns from its mistakes all the time. It's like an army that mounts a war. Each time it mounts a war and the war fails, it keeps memory of that war and makes sure that it doesn't mount that same kind of war again. So we cannot fight the same war we fought in, let's say, Afghanistan, the same way we did it. Only humans do those kind of mistakes. The immune system does not. So the immune system priming, it does. There is no way, if there is another antigen that is available, only if your immune system is functioning well, the immune system is actually going to send what they call naive cells that are going to go there and try to identify what's going on. They are going to fail as much as they failed in the first coronavirus till you figure out why they are failing in the first place. So I think this theory that is being propagated by some smart people, most of the time they are smart because they are truly smart and they get these things because they know the layman is going to get confused and no scientist is going to go over media trying to explain the nitty-gritties of this thing because it's complex. But the truth about it is that that's not how the immune system works.
Yeah, and the fact that recently, because I work here with some French guys, and it's always really you try to tell them these things, and they're always like, "Oh, mais non, c'est pas comme ça, tu vois." And then the fact that Louis Montagnier, I don't know, the Nobel Prize winner, came out and said something. It was really like, "Yo, if he said this, then it's like that," and so it's really terrible. So I was like, it's good sometimes we try to debunk all this that is going around, because then our people back home, most important as they are French, they will just listen just to that, and that's what they believe in, and they don't hear and get nothing. So
yeah, Crispo, I agree with you that we have to debunk it. But one thing too, the greater problem is the mindset of us, our people. And changing mindset takes forever. It takes a lot of input for you to be able to change mindset of people. Trust me, the scientists, you even go out and try to give the correct information. But as once as somebody tells them that, hey, there is a chip that has been put in that vaccine, that is where everybody just goes for it. At times, I don't really understand, right? I'll give you an example. I gave a talk to a group of scientists back home there. I think before that talk, a few people had gotten the vaccine, and after the talk, Prof. Leke asked, how many people will get the vaccine? These are scientists, not laymen. After the talk, how many people will get the vaccine? Just one person showed up. That was 4 hours of vaccine talk. Now, why will you not get the vaccine? The most popular reason is that, oh, the government did not give us information about it. They did not give us information, but we have been giving you information for 4 hours.
yeah.
Yeah. So what information do you want again? then another person wakes up that, hey, you know, when the ministers go on TV, they are giving them a placebo, like saline. They're not giving them the real vaccine. That's what I've told them. So the ministers will take something else. And why are they keeping the real vaccine there for them? It means there's something fishy. These are scientists. So what I'm saying is that it's a mindset, right, that we really, really need to get out of it. Now, the way some people get out of that is when it hits them. Like one of my friends here, you know, in Texas, my cousin was just telling me about him. He was one of these highest anti-vaccine people that, hey, he's not taking it. Then 2 days ago, he went to the ICU. He went to the emergency. He was not sick, but somebody was sick. He took the patient to emergency. And when he sat there, they brought a 70-year-old that has died, brought another 55-year-old that just died from COVID. The next day, he called my cousin that where can he get the vaccine? So there are some people that learn the hard way. You know, there are some people that will get the information, but unfortunately, with us, we probably spread more of that information that doesn't hold the scientific, you know, principles well as compared to the science itself. And one of the reasons is because we scientists, we don't know how to package it, right? We don't know how to package it in such a way that it should touch people. It's a limitation because at times you will be forced to use the scientific jargons. At times you don't really know how to tweak it a lot because you feel that if I tweak it like this, it's going to change the notion about it. But somebody will just say, hey, that vaccine has a chip, and when they put that chip in you, they're going to use it to track you. And to know that the chip is there, take a coin and put it where you were vaccinated, it's going to stay there. Seriously, if you don't take the vaccine, as long as you have oil on your arm and you put a coin there, it's going to stick there. So they have direct evidence, right? Let me put it like that, that, hey, this person is speaking the truth. And when you come as a scientist, whatever you want to say, you're just giving them theory and nothing practical to see. That is it.
Thank you very much, Dr. Crespo, for bringing this topic, very important topic. And we had said it here. I think we had an expert from Germany, I just forgot the name, who gave us a talk on effective communication. And if I can recall, one of the things she said was that, you know, when you are communicating, you are targeting people's emotion. The conspiracy theorists, they target the emotion in their communication. They empathize in the way they communicate. And that's why their information is believed more than that of those of the scientists. And you just took it from me. I was about to ask you, why is it that scientists cannot communicate in a way that touch people's emotion? And I still gave the answer to myself. It's easier to target your fears than to target your motivations. If I tell you something that you risk dying from, or something that can affect you, or something that is dangerous for you, it's easier for you to get that than for me to tell you how you can make $1 million in 2 months, or how you can make $1 million in 1 month, or any of those kind of motivations. So it's easier to target your fears than to target your motivations. And that's why those who are the vaccine conspiracy theorists, they find a way. And I remember we even talked about the name of the enzyme that is being used in the nanoparticle. They call it luciferase. And you say, okay, they say, okay, it's called luciferase. When I shared this, was there no other name to call that enzyme? Must you use Lucifer? Why? That's to tell you that these people, this thing is 666. There is Lucifer involved. Just here, they say that particle is luciferase. So you see, everything that is involved, they try to make some meaning out of it, and that aggravates the fear factor, and that's why they communicate better. But I think that we as scientists as well cannot do more than just communicating the truth and the way it is. And even if it means adding comedy to it, it is attacking a different aspect on the psyche than those who are communicating the conspiracy theory. We are targeting 2 different aspects of the psyche. Some are targeting the fears, some are targeting the motivation. Maybe if we reverse it and target their fears by communicating them, let them know more of the danger of not vaccinating rather than the importance of vaccinating. Maybe just like your cousin, a lot of people will rush to go get their vaccines. So maybe we should target the same aspect in our communication and see how that works. Christelle, who next?
Merci beaucoup à tous les intervenants. Docteur Kate, tu veux nous dire quelque chose?
Oui, merci beaucoup Christelle, merci aussi beaucoup à Kenji et à Monop et à toi Elvis pour, n'est-ce pas, déjà pour la présentation et déjà pour tout le monde pour cette discussion qui est très riche ce soir. Juste pour dire que j'ai beaucoup appris, beaucoup de mes questions ont déjà été posées. Donc, je vais juste poser juste une question à Kenji. Est-ce qu'il y a des nouveautés vis-à-vis des vaccins qui vont être dirigés spécifiquement contre Delta? Et quelle est ton, je vais dire peut-être opinion vis-à-vis Novavax ou Novavax, le nouveau vaccin? Et l'infection à Delta.
Okay. So Elvis used to tell me when I speak French in Cameroon, he used to tell me that I'm mother French. Like I'm the worst person. That's what I failed French, I think from 5. I failed French in UB. If you look at my transcript in UB, that's what is there. But I still love the French language. I try to understand it. So I'll just try to rephrase the question to be sure that I'm not answering something else. So the first one, Dr. Kati is asking if there will be a specific vaccine against the Delta variant, if I get it correctly. And the second one was commenting on the Novavax. Okay, I see Elvis nodding the head.
You are doing well, sir.
Okay, thank you so much. Thanks. So one thing, specific vaccine against the Delta, yeah, but come to think of it, what we have now is working. One thing also have to consider in terms of vaccination is look at the logistics. Now, if you want to produce a vaccine that is specific against Delta, another variant will pop up tomorrow.
Yep.
If people are not vaccinated, another variant will pop up tomorrow. Now, but the way I want to look at it is how can we best produce the vaccine in such a way that the antibodies are broadly neutralizing? I think that's the best approach to go on with, in such a way that antibodies are broadly neutralizing, that even if these variants continuously to pop up, at least the antibody that you have produced is still able to neutralize the virus. Because if people don't get vaccinated and we don't put on all these public health measures, as long as replication occurs, a new variant is going to pop up. We never knew that something was going to pop up as dangerous as Delta, but now we have Delta. So for me, I will highly recommend that in terms of vaccine formulation, we should formulate vaccines that have broadly neutralizing antibody in such a way that if another variant pops up tomorrow, at least it should still be able to neutralize it. And as I say, things change. It may reach a stage wherein we may look at COVID as flu, depending on the kind of mutations that are occurring. We may need to update the vaccine yearly. But I will not really say that updating it with respect to a particular variant. I would really like to see something that you update the vaccine that can take care of any slight mutations that occur, unless it is a major mutation that may require some kind of update. So that's a comment I will have on that. And regarding Novavax, seriously, I don't read a lot about Novavax. I know Dr. Fuma, he's the one that follows up probably Novavax and all the like. So I'm not sure I'm the best person to comment when it comes to Novavax.
Dr. Muno?
Yeah, so I think right now the CDC and others are holding back a lot on Novavax because we have a lot of things already available. But the data initially, I've not seen new studies showed that it was very efficacious against the new variants that were coming out, not the Delta. I need to figure out exactly how it's going to do with the Delta because it's having some logistic problems right now. It's actually ready, but they are unable to produce the quantity they need in order to distribute. So they're actually having more of logistic problems. That's why they have not applied for an emergency authorization. So I think as soon as they fix that, they're using a different kind of technology. So this may be able to, we need to test it in real life and see how it goes. I think clinical trials need to be done. They have not done them rapidly just because of that logistic issue they're having with the Novavax. But it's an amazing and promising different technology that I think would help us in the pandemic. Dr. Kenji, I have a question. How about mixing vaccines? So the issue of mixing vaccines, I know there are other hands that are up, but what's your take about the issue? Those who are at the town hall of mixing vaccines, there have been some amazing studies showing that mixing them may prime the immune system more than just giving the same vaccine and trying to mix the adeno vaccines with the mRNA vaccines and see exactly how the immune system responds to that. So,
for me, as long as the mixing vaccine is beneficial to us and is beneficial to the immune system, why not go for it? Everything is all about science. Set up the clinical trial, run the experiments, and show the data. If the data is convincing, but for now, there's really no clear-cut data that if you take one dose of Pfizer and one dose of Moderna, it's going to make a huge lot of difference as compared to sticking to what it is, right? So for now, what's the need, because all these things are also logistically challenging. It's not all about what you see in the lab. How do you go on to operationalize something like this? Is it like you just go to any facility, you take whatever is available? If it helps, in terms of logistics and the data are clear cut, we as scientists, we are also data driven, then why not go for it? But it should be able to give some benefit. It's not all about people just advocating that, we should be able to, to mix and match vaccines and all the like. But adenovirus, plus mRNA, that's a combination that's never been tried before. We look up to see, clear clinical data, clinical trial data from those. And if it works well, then fine, let's go for it.
Yeah, thank you.
Thank you, everyone. We are already getting to the time, to the end of the meeting, but you want to call on Mr. Ngong for his question?
I think just before the question, I think there is some data about mixing vaccines, and I think I saw it recently in a meeting. I don't know if I'm correct, Mono. I don't know, probably you are the guy looking at the updates every day, but I saw that AstraZeneca then Pfizer had a better response than two Pfizers.
Yes, I think
So
you're
there
right.
there is some data. There is some data in the UK, not really than two. There is some data in the UK that shows that AstraZeneca then Pfizer is better than AstraZeneca, and maybe as good as Pfizer and Pfizer or Moderna, Moderna, maybe as good. So that's why those who had AstraZeneca or those who are in countries where they were limited in vaccines that could get now an mRNA vaccine. I think this was done in the UK just because they had issues of shortage and all of that. But getting Moderna then AstraZeneca does not produce the same effect. But getting AstraZeneca, then getting Moderna or Pfizer, so the mRNA as a second vaccine could, but then we need more studies. I think this was done just in the UK.
Yeah, but then look at it logistically. I mean, mRNA is doing better. So if you take, like adeno, which is inferior, then you take one adeno and add mRNA to it. Logically, it should be able to drive it a little bit, right? But how much difference does that make in terms of, putting that like a policy and all those things is what, probably a larger study, should be able to take a look at.
Yeah.
Yes, please, you have the floor, Mr. Ngong.
All right. Good afternoon, everyone. It's Vinashis Ngong. I have a question, and I'll direct my question to Dr. Former. And before I ask the question, I'm just going to give a little bit of context as to why I'm asking that question. So just yesterday, I'm an anesthesia provider. So we had a peer review meeting, and one of the cases we discussed was a gentleman that came for an EGD and a colonoscopy. Procedure went well, did great. He went home. After midnight, he kind of came up with some neurological symptoms, some numbness, tingling on his toes, fingers. About 30 minutes later, he could not walk while he was at home. They called EMS, and by the time they got to the hospital, he died. And so while we were discussing the case, one of the anesthesiologists that I work with, she's very anti-vaccine, by the way. She has not received the COVID vaccine. She would not take it. She made a point to me. She claimed she knows about 6 people who had the vaccine, and within a week of having the vaccine, they had a stroke. And so me thinking, oh boy, and with surgical procedures, one of the biggest risks is blood clot, especially with long procedures. The patient is laying still on a surgical table, no movement, there's venostasis, so that's one of the, issues that we see with some patients, post-op, is that they might form a blood clot. And so the question came up, if her assumption is true, which is knowing 6 people that have had the vaccine and then had a stroke within a week, should we kind of hold off on, or postpone elective procedures for patients that have had the vaccine and they're coming in for a surgical procedure just because we're afraid that their risk of forming a blood clot is higher? Do you think that's something we should consider? What have you seen as far as like in those patients that have come up with a clot after the vaccine? How soon does it happen? Is there like a time frame? Would you recommend that from an anesthesia standpoint? Should we say, hey, if you've had the vaccine, we'll probably say hold off for maybe 2 weeks before you get your elective procedure done? I mean, what's your thought on that?
Okay. I don't know if there's any hematologist else on the forum, but being a hematologist, I would. There's some echoing going on, please. Let me try to fix that. So being from the hematology standpoint, we don't have any real recommendations from ASH, which is our body of concerning patients who are vaccinated and who are going for elective procedure. You need to treat them like any other group of patients whom you think they have risk factors for getting clots. And I will, but if a procedure is not very important, if it's not an emergency, if it's a procedure that I think can be deferred, each time someone has some kind of an intervention done on them, I may just want, for caution's sake, defer it for a while. But in terms of being an extra risk factor, it's not been documented that getting vaccination is an extra risk factor. Getting COVID, on the other hand, could be. We know that COVID is a very hypercoagulable state, and we tend to place these COVID patients actually on the anticoagulants. If they had moderate disease, there has been studies that has proven that patients with mild and moderate diseases tend to get clots more, and also that placing them on anticoagulation, Dr. Brunhilde will tell you, maybe in the ICU, it may not work. The studies show that in the ICU, there was no difference, but those who were out of the ICU, there was a big difference. And I think most hospital systems still do it, still either prophylactically anticoagulate our patients who are COVID positive and who have moderate to mild disease. And those who are in the ICU, they get anticoagulation either way for something else because they are intubated and they're unable to move. But there have been no difference in the clinical trials that came out. But concerning your outpatient situation, I would treat each patient differently because I know those patients have different factors that could lead to clot. No one has studied those 6 patients. Do they have antiphospholipid syndrome? Do they have other clotting, pro-clotting conditions that nobody saw? Do they have some form of different mutation, let's say or prothrombin gene mutations? All these things, there are few patients that they are citing. So people tend to cite specific emotional examples without looking at the data as overall. I will tell you, I do consult in a hematology big clinic in New York. We have not seen, not that I've seen post-COVID ITP, one case who is doing quite well. I have not yet seen VIP. I have not yet seen patients who came for elective procedures and developed clots in the big practice we're seeing. We're seeing just hematology patients. I've not seen them yet. So these isolated cases are cases you can actually report. And if we see huge numbers, because science is data-driven, we may be able to sit together and hash, which is made up of big hematologists, they will sit together and they'll come out with a policy. But for now, I think each patient should be treated one patient at a time, how obese they are. If they have risk factors for clotting, then you may start them on prophylactic anticoagulation. Before that, and you guys too are not very comfortable with patients being on anticoagulation and going for surgery. So those are patients I may start on a heparin, but it's all one case at a time. So, and I think if you are worried about a case, you should call for a consult and get a hematology opinion.
Thank you very much.
Okay, merci beaucoup. Madame Teke?
Sorry, this is Mr. Teke.
Sorry. Sorry.
This
I'm
is
sorry.
Teke Joseph. I'm a nurse anesthetist from Bamenda, Cameroon. I want to give my. I am very happy with this
Mr.
seminar.
Teke.
Yes.
Sorry.
It's okay. It's all right. I am very happy with the exposés. I'm learned so much from the doctors. I want to give my personal experience. In fact, I am worried because I've not had the vaccines yet myself because I have an allergy in sulfonamide. So I wish to know if, because recently Johnson & Johnson entered the regional hospital and I wanted to take it because it's just a single dose vaccine. So I just wish to know if it's a contraindication, an allergy to sulfonamide, if it's a contraindication to the COVID vaccines, and if the Johnson & Johnson vaccine could be a good one for me. And again, because I came late to this seminar, I wish to know if there's a website where we could go and download everything that passed today so that I can still maybe re-listen to it and get myself better acquainted to everything that was said during the Zoom meeting. Thank you so much.
So sulfonamide allergy is super common. It's not an allergy that is not common. I think Dr. Brownhilda is here. She's going to say it too. It's very common, and that's when you've been having. We know cases of fancida allergy. Those who were taking anti-malaria drugs have had Stephen Johnson syndromes and all of that. But from the knowledge I know, I think Johnson & Johnson does not contain any sulfonamide-derived product that is going to cause you an allergy. And I believe it's a very good vaccine because it's a single dose and the efficacy was as equivalent as the vaccines that are available in Cameroon. Because in Cameroon now we have the Ciano Pharma, we have the AstraZeneca, we have Johnson & Johnson, we do have the Pushnik. So among all those vaccines, it's a great choice if you want to take. So I would encourage anyone to get vaccinated because most of those vaccines do not have any cross allergy with sulfonamides. I may be wrong, but if there is someone who wants to, we have a lot of experts in the field who are here. So Dr. Brownhilda takes care of a lot of patients in the ICU. I don't know if they have seen anyone with a cross reaction.
I think Dr. Former will want to answer. Ayok Former might want to add some more information to that.
Hello, everyone. Good evening. Can you hear me?
Yes.
Yeah, sorry. I just wanted to tell Mr. Teke that I've got multiple allergies. I've got allergies to sulfur drugs. I have allergies to bees. I have allergies to a lot of antibiotics that are out there. So many things. I've got like every single allergy you could think of, but I am fully immunized. I've had 2 AstraZeneca vaccines, the first and the second dose, and I'm alive. So I want to assure him that if he has the sulfur allergies, the AstraZeneca or the Pfizer or the Moderna or whichever one you have there will not kill him. Because if I had to die, my allergies are so many that I am even really careful just trying to eat. I can't even eat sugar cane, simple sugar cane that everybody eats. I can't eat it. I have allergies to seafood, allergies to sulfur drugs, allergies even to certain antibiotics. So it's safe, I'll assure you. I took it and I'm alive. So don't get scared. I think you are in the medical world and you are seeing patients, you're in the front line. It is really important. Maybe if you take it, they can give you some antihistamine. If you're very concerned, talk to your physician and he will know what to do when you take the vaccine. But trust me, if this vaccine had to kill someone, then it would kill me because I have lots of allergies. So, but I'm alive and I want you to just believe that it made me alive and you can take it. So please don't be scared. Thank you.
Thank you so much, Dr. Ayok, for that reassurance. I'm really glad that you are able to give that personal testimony that will help our brother Teke to take action. And I know you're always very outspoken. She's also very allergic to any system that does not enforce drug regulation. So thank you so much. She's really a wonderful person we have in the house. Thank you so much.
You're welcome. Thank you.
Merci beaucoup, merci à tout le monde, merci à tous les participants. Nous sommes arrivés au terme de cette session qui était très enrichissante. Merci beaucoup, Dr. Kenji. Merci à chacun, merci au chairman et merci à tous d'avoir participé à cette nouvelle édition de Cameroon Town Hall. Elvis, tu veux clore la session? Merci d'avoir commodéré avec moi aussi.
Thank you so much, Christelle. It's always a pleasure having you. I'm so happy each time you are on the panel. I want to thank you so much. Thank you to all our participants for today. We are so glad that we had really many people tune in. We had more than almost 40 participants today. And we are happy, and we continue to ask you to dial in every fortnight for another edition of the Cameroon Town Hall for Healthcare Professionals. And we had a question, and I want to give you the answer. You can have all the editions of the Cameroon Town Hall for Healthcare Professionals from the first day to the last day on our YouTube channel. We are doing our best to upload and edit all the versions so you get the best experience when you dial in. So that is the link on the chat, which I've already put there. You can watch the last two editions already uploaded, and many more uploads are coming on. You can also watch this recordings on our website or on the Facebook platform, because each time we go live, the recording is stored on Facebook automatically. So we are doing everything to make sure that this very educative lectures and presentations can become a resource for students, a resource for experts. So if you want to learn anything new from any of the topics that we have had here, you just go to our YouTube channel and you spend some quality time and listen to our experts. So once again, thank you so much. We were able to get the details from Kenji on how dangerous the Delta variant is, and we've had so much of information, and we want to thank you so much, Kenji, for this very educative session. You told us that one of the dangers of the Delta variant is its ability to spread more quickly, and that the Delta variant is more contagious. And we heard from you that it is about 40 to 60% more transmissible as compared to the Alpha variant, which was the first type of COVID-19 that we had. We've also heard that more viral particles have been found in airways of patients infected with Delta variants, as far as the studies you cited showed. And you also said viral load is about 1,000 times higher in people infected with Delta as compared to other variants. And it is also very likely that the Delta variant is more infectious during the early stage of the infection. And when you ask the question, why is it that the Delta variant is more transmissible? And you gave a scientific answer that several mutations may affect the immune response, and that the P681R mutation cause effective cleavage and priming, which may increase replications. And that could also account for why there is that high transmissibility. And that more people with the Delta variants are in the ICU as compared to other variants. And that more people, there are more deaths with the Delta variant. And these are from some specific studies that you cited. And we said the vaccine and convalescent sera showed reduced neutralization of the Delta variant, and that only modest differences were shown in the effectiveness or ineffectiveness were noted with the Delta variant as compared to other Alpha variants or the other variants. So we also said that there is no difference in viral load when comparing unvaccinated individuals to those who have the vaccine or who have vaccine breakthrough infection. So there is no much of difference in terms of viral load. We also said if a vaccinated person becomes infected with the Delta variant, then they could be a source of transmission of COVID-19. So it is important that we continue to mask ourselves, as you mentioned at the beginning. And we also said that vaccination is associated with faster decline in viral RNA load, and which is also one of the reasons why we keep saying that despite the dangers of the Delta variant, vaccination is key. And you said the mRNA vaccines are highly effective in preventing symptomatic and severe COVID-19 associated with Delta infection. So these are some of the highlights you brought from studies which you were able to scan before doing your presentation. And you ended by saying there is a third dose of mRNA vaccine a study showed that a third dose of mRNA vaccine in transplant recipient had substantially higher immunogenicity than those in placebo. And this was a study that was done in immunocompromised person. And so this is also to show that it is possible that we might be getting 10 doses of the vaccine. And I want to thank you so much for this very scientific also, but you made it very easy to understand by the layperson. And now if we go out there, we can say the Delta variant is very dangerous. Let's continue to take all the barrier measures. Let's put on our masks. Let's not forget the basic principle of hand washing and masking, as well as getting vaccinated. We have agreed that conspiracy theories will continue. It's a battle. They will not stop at any point. They will continue to look for all the cracks in this science that you have presented today in order to convince the layman not to take the vaccine. But as scientists and as healthcare experts, let's continue to do our work. Let's continue to call back home and tell our brothers and sisters to continue to protect themselves. And of course, take advantage of any available vaccine and get vaccinated. Once again, it was a pleasure having you on this session of Cameroon Town Hall. We look forward to see you again in 2 weeks' time for yet another edition. Thank you very much. Have a very wonderful weekend. Bye-bye.